All right, welcome to class, everybody. So our lesson today, section 5.7, doesn't really have any new stuff that we're learning. It's more so learning how to combine everything we've learned about factoring so far. So as a quick review about factoring, factors are things that are multiplied together. And so if we're trying to factor something, we're basically trying to change the polynomials to be in a form where you have smaller polynomials multiplied together. So I like to kind of think about the idea of factoring completely in the terms of numbers first, and then we'll extend it to polynomials. So if I was to factor the number 30, I could say, well, 30 equals 5 times 6, but this is not completely factored because 6 can be factored further. And so with numbers, if you're trying to completely factor a number, you break it down into factors, and then you look at the individual factors and see if you can break that down even further. So 6 is 2 times 3, and those cannot be broken down into further factors. And so 30 equals 2 times 3 times 5, and that would be the fully factored version of 30. And we do the same thing with with polynomials, because I could factor this polynomial because both of these terms are divisible by 6. I could factor out a 6, which leaves me with x squared minus 4. And this is factored, but it's not fully factored or completely factored because x squared minus 4 is a difference of squares. And so based on the stuff we learned last class, we could write this as x minus 2 times x plus 2, because a difference of squares can be factored like this. So this would be considered fully factored. Even though this is technically factored, it would be marked wrong on your homework because it's not fully factored. Does that make sense? Kind of the idea of fully factoring something? It's like you break it down until it can't be broken down any further. So what we're doing today is we're combining everything that we've learned about factoring. So the first thing we learned when we started factoring was that you could factor out the greatest common factor by looking at all of the terms and seeing if they have any factors in common. So like in this case, since they can all be divided by 4, we factored the 4 out, which left us with this polynomial on the inside. So that's what we started off learning. So let's just do a check-in on a scale of 1 to 5. How do you guys feel about that concept? Okay, awesome. So then the next thing we moved on to was learning how to factor by grouping. So factoring by grouping works when you have 4 terms and you split them up into 2 groups and you factor the groups individually. So like in this case, these 2 had a b squared in common, these 2 had an 8 in common. And when the thing that you're left with matches, you can factor that out, which leaves you with the b squared plus 8. And so that's factoring by grouping. Scale 1 to 5, how do you guys feel about that concept? Okay. And then the next thing we learned about was factoring trinomials. So factoring trinomials is when you have something with 3 terms and you multiply the first and last term. So like you'd go 6x squared times negative 20 gives you negative 120x squared. And then you look for 2 things that multiply to this and add to this. So in this case, 15 times negative 8 equals negative 120. And so you break up that 7x into 2 terms. And the whole point of this trinomial trick is to make it so you can do factoring by grouping. Because if you only have 3 terms, you can't really split them up into 2 groups because there's not an equal number of terms or an even number of terms. But once you break it up into 2 terms, then you can do the factoring by grouping and get it into factored form like that. So scale 1 to 5, how do you guys feel about the trinomial trick? Okay. And sometimes this one was kind of hard because it might take you a little while to realize that 18 times 5 equals 120. But most of the numbers should usually be pretty easy to find. And then the last thing we've learned about is how to factor special cases. So we have 3 different special cases. We have a difference of squares when you have 2 perfect squares subtracted. difference of cubes where you have perfect cubes subtracted and two perfect cubes added together. And we learned yesterday, or Friday actually, that you can factor them like these formulas show. So I don't really care if you memorize these two, you just need to know that they exist and you can look them up whenever you need them. This one, however, we will use it very frequently, so you need to memorize that a difference of squares can be factored like this. Also, another thing to notice is you can't factor a sum of squares. So if you have two perfect squares added together, the only way you could factor it is if you had imaginary numbers. And we haven't learned imaginary numbers yet, so we're not doing those types of factoring. So this one's the most important one, but these ones will pop up occasionally, and you're welcome to look up the formula when you need them. Okay, so that's a very quick summary of all of the types of factoring we've learned so far. So what we're doing today is we're learning how to factor completely, which is basically figuring out how to know which thing you do. Because we have these 4 different options of what we can do, and we need to be able to tell which one we need to apply in order to factor the polynomial completely. So this is the summary of what you need to do. So you always start off by factoring out the greatest common factor. So you look at all the terms and you see if they have anything in common. If they do, factor that out. And then after you do that, and sometimes you won't be able to because sometimes there isn't a greatest common factor. But after you do that, then you look at the remaining factors and you decide out of these 3 things what you need to do, depending on how many terms there are. So usually, if you have 4 terms, it will usually work out nicely to do factoring by grouping. Not always, there are some cases where factoring by grouping won't work. But if you have 4 terms, it's likely that they've set it up in a way for you that you could do factoring by grouping. If you have 3 terms, well, 3 terms is a trinomial. And so you can just use the trinomial trick to turn it into 4 terms so you can do factoring by grouping. And then if you have 2 terms, you want to check and see if it's one of the special cases. So there's difference of squares, difference of cubes, and sum of cubes. And so you just look at what's in the 2 terms and you say, are any of those perfect squares or are they perfect cubes? And you can do the factoring from there. And sometimes you'll end up with 2 terms that can't be factored any further. Like, let's say you factored out a common factor of 6 and you were left with, I don't know, like x minus 2 or something. In this case, you can't factor that any further, so you just say you're done. But you always want to check and see if it is a perfect square and if you have a difference of squares or cubes. So this is the basic idea of how you get something completely factored. And after you go through this, you always want to check the factors that you end up with and see if they can be factored any further. So today's lesson, I just want to go through a couple of examples that illustrate kind of your thought process of how you should approach these problems. But there's not really any new factoring information. It's mostly just about how do you know what you can do and which method to apply. So I'm going to go through 4 homework problems, but I'd like you guys to keep your laptops closed while I'm working on it so you can watch the thought process of how to approach them and then try the problems on your own, because the main focus for today isn't necessarily strategies for solving individual types of problems. It's more about knowing when to apply which types of strategies. Okay, so this is the first one I want to go over. So on this one, you always look at your terms and see if they have anything in common. So in this case, I have 3 terms. And do those 3 terms have anything in common? Yep, they have an x plus 2 in common. And if I divide the first term by x plus 2, I'm left with x squared. When I take the next term and divide by x plus 2, I'm left with minus 4x. And then when I look at the next one and divide by x plus 2, I'm left with plus 4. So this is factored form because I have 2 things that are multiplied together. But I need to see if it's fully factored. So I look at my first factor and I ask myself, is there any way I could factor that further? Nope, x plus 2 is already fully factored. Then I look at this one. Is there any way that that could be factored further? Yep, And which method would I use to factor it? Am I going to do factoring by grouping or a special case or a trinomial trick? Yep, this one is a trinomial trick because I have 3 terms in there. So I'll do 4 times x squared, which gives me 4x squared. And what 2 things multiply to 4x squared and add to negative 4x? Yep, negative 2x and negative 2x. So I'm going to split this up into negative 2x, and this whole thing is still being multiplied by the x plus 2 that I factored out earlier. Then I'll split that up into 2 groups, factor the common x out of the first group, and a negative 2 out of the second group. And again, this whole thing is still multiplied by x plus 2. Then I'll factor out the common x minus 2's. And that leaves me with x minus 2. And that is, again, still multiplied by the x plus 2 I factored out earlier. And so this is now my more factored form. So then I need to look at it again and say, okay, well, x plus 2 we know can't be factored further. What about x minus 2? Nope. Excuse me. And so both of those terms are the same, so I can't factor that any further because each of the factors are fully factored. And you could, if you wanted to, write it as x plus 2 times x minus 2 squared because 2 of the factors are the same. You don't have to do it that way, though. You can just write it out with the 3 factors because it means the same thing, just a different way of writing it. So again, overall strategy, always factor out a common factor if there is any, and then look at your remaining terms or remaining factors to see if you can factor it further. Let's do another example. Okay, so on this one, what's my first step going to be? Perfect. So if I look at these 2 terms, what do those have in common? Yep, they have an x squared in common, which leaves me with an x cubed plus 64y squared, or y cubed, excuse me, when I factor that out. Okay, so now I'm going to look at each of my factors. Can I factor x squared any further? Nope, already fully factored. What about x cubed plus 64y cubed? Yep, because that's a sum of cubes. I have 2 perfect cubes that are added together. So I'm going to use my sum of cubes formula, which hopefully I can remember it correctly. I think it's a plus b times a squared minus ab plus b squared. Anyone have that in your notes? Is that right? Because I don't have it memorized. It is, right? Okay, sweet. So this is the sum of cubes formula. And we have an a cubed, and in our expression, we have an x cubed. And so everywhere we see an a in the formula, we're going to write an x. And then in the b cubed spot, we have 64y cubed. So everywhere we see a b, what are we going to write? 4 and a y. Because if I do 4 cubed, that gives me 64, and y cubed gives me y cubed. So everywhere in this formula that I see an a or a b, I'm going to substitute these in. And that gives me x plus 4y for this part. And then the a squared will be x squared. The minus ab will be minus x times 4y, which is negative 4xy. And then the b squared is going to be 4y squared, which is positive 16y squared, because 4 squared is 16, y squared is y squared. And that is what the sum of cubes factors to. And then I still have the x squared out front that I factored out earlier. Now, I need to look at this and say, can I factor this even further? So I look at it and I say, well, x squared, no. This term, no. And this term might look like it can be factored further because it's a trinomial. However, trinomials that come from this formula can actually not be factored unless you have imaginary numbers. So if you got a trinomial from this equation, then you can just leave it and know that it's fully factored. But typically, if it doesn't come from a situation like that, a trinomial would be able to be factored further, and you would, you'd factor it further. Because not all trinomials can be factored, but whenever they give you a trinomial, they're going to design it in a way where it could be factored usually. But the exception is with a sum of cubes because they're having you practice something different. Any questions on that or the strategy for that? Yeah.
Can you go over again how you got the 16y squared? Because I just have 4y squared. I probably just.
Yeah. So in the formula, it's in this part of it, right? And b equals 4y, and you need to square the whole thing. So the 16 came from the fact that 4 squared is going to be 16, and y squared will be the y squared. Yeah, great question. Any other questions? Okay. The next example I want to do is question 13. So on this one, what's my first step? Yep, you always want to check and see if there's a greatest common factor. So we'll look at all three terms. And what do all three terms have in common? Yep, they both have an x squared and a y. Is there anything else they have in common? So these two are both divisible by 5, but that one's not. 3? Yeah, I think that's right. Because 48 divided by 3, is that 16? And then x to the 4th divided by x squared would be x squared. Negative 120 divided by 3 is going to be negative 40. X cubed divided by x squared is going to be x. Y divided by y cancels out. 75 divided by 3 is 25. And x squared and y divided by x squared and y just cancels out. Now it's possible that maybe there was a bigger number that could have been divided by, like maybe 3 is not the biggest one, but we can tell by looking at these results and seeing if these have any common factors. And it doesn't look like it because 25 can only be divided by 5 and 16 can't. So it looks like 3 really is the greatest common factor. But if you're ever not sure if you found the biggest number, just look at the result of factoring out the number you think you can factor out. And if there's any common factors in there, then that means you didn't catch the biggest one. And then you just redo that. But in this case, we did get the biggest one. So the next thing I'm going to do is I'm going to look at my factors that I have and decide if this is fully factored or if I need to factor further. So this factor is already fully factored. You can't factor it down anymore. But what about this one? Is it possible to factor that any further? Yep. And which method am I going to use? Yep. I'm going to use the trinomial trick because it's a trinomial. It has 3 terms. So I'll do 16 times 25. And if I remember correctly from my last class, I think that's 400. Is that right? Anyone? Okay. So I get 400x squared, and I'm looking for something that multiplies to 400 and adds to negative 40. What 2 numbers multiply to 400 and add to negative 40? Say it again. I heard a couple. Okay, perfect. Like that? Yep, that should work because negative 20 times negative 20 will be positive 400. X times x will give us x squared. And if you add them together, that would equal negative 40. So I'll rewrite that and I get 16x squared minus 20x plus 25. And all of that stuff is multiplied by the 3x squared y that we multiplied earlier. Then I'll split these into 2 groups. The first group has a 4 and an x in common, which leaves me with 4x minus 5. The second group, I can pull out a negative 5, which leaves with 4x minus 5. And that whole thing is still multiplied by the 3x squared y. Then I'll factor out the common 4x minus 5. And that leaves me with 4x minus 5. And that is still multiplied by the 3x squared y. So this is a more factored form, but I need to tell if I really am fully factored or not. So we already determined that this one can't be factored any further. What about 4x minus 5? Can that be factored? No, because there's no common factors, there's no exponents, and so those two are done. If you wanted to, you could write this as this squared because you have two factors that are the same, or you could just leave it like that. All right, so scale of 1 to 5, how are you guys feeling about the process of how to decide what to do? Okay, so this next one, this is the last example I'm going to do, then you can work on your homework. If we look at this one, what is our first step that we always do? Yep, we always check to see if there is a greatest common factor. So when I look at these 4 terms, is there anything that all of them have in common? Nope, so that means I'm going to skip that step because there is no greatest common factor. So then I look at it and I say, okay, well, what should I try next? Yep, I would want to try factoring by grouping because I have 4 terms and 4 terms are easy to split into 2 groups. So if I do that, I split them into 2 groups. The first one has an A in common and I get A minus 4. The second one is a difference of squares because 4 is a perfect square, B squared is a perfect square. And so that would factor into 2 minus B and 2 plus B by the difference of squares formula. However, this doesn't really help because once we have them in these 2 groups, the 2 groups don't have anything in common. This has an A and an A minus 4, but this one has a 2 minus B and a 2 plus B. So you can't continue this process any further because the groups don't have anything in common. So it was a good try, and it's what you would typically want to do if you have 4 terms, because a lot of the time it will be a polynomial that can be factored by grouping, but in this case, it didn't end up working out. And this won't happen very often, but when it does happen, you kind of just have to look at the overall structure and play around with ideas until you find something that works. So if we look at this one, I'm noticing that we have some A's over here, and then we just have a single B squared that's being subtracted. And so any ideas on how maybe we could approach this given the structure of it? Yeah. Okay, yeah, so you're thinking maybe factor this as a trinomial. Okay, yeah, so that's a great idea because if this ends up giving us 2 factors that are the same, so they're squared, then we'll end up with something squared minus B squared, which would be a difference of squares, which would allow us to factor the entire expression. So let's go with that and see if that leads somewhere. So I'll take 4 times A squared, that gives me 4A squared. And what are 2 things that multiply to 4A squared and add to negative 4A? Say it again. Perfect, yep. So I get negative 2A plus 4. And by the way, if these 2 numbers end up being the exact same, that means that it will end up being a perfect square situation. So this was definitely the right direction to go. And I'm going to write my negative B squared out here so I don't forget about it. So then I'll split it up into 2 groups. I have an A in common, which leaves A minus 2. The second group has a negative 2 in common, which also leaves A minus 2. And then I have this negative B squared at the end. Then I'll factor out my common A minus 2 terms. So I get A minus 2. And when I take this first term and divide by A minus 2, I get A. When I take this one and divide by A minus 2, I get negative 2. And then I still have this minus B squared. Now, this right here is not factored yet because what we have is something minus something. And so this isn't in factored form, but this part of it is. And because both of the factors ended up being the same factor, we can write that as A minus 2 squared minus B squared. And this is a difference of squares because you have 2 squares that are subtracted. So you can use the difference of squares formula, which says that anything squared minus another thing squared is the difference of those two things times the sum of those two things. So on the formula sheet I gave you, they were A's and B's, but since we have other A's and B's in this one, I just changed it slightly. So since I have something squared minus something else squared, I can rewrite this as the first thing, so A minus 2, minus the second thing, so I'm going to minus B, and then multiply it by the first thing, so A minus 2, plus the second thing, which was the B. And that's just with the difference of squares formula. And so this would be the factored form of that polynomial. And again, this is not a typical type of problem. This is kind of like a unique situation because usually if you have 4 terms, factoring by grouping will work. But if it doesn't, then you may have to try something else like this. So I'll go back to this slide in case you want to take any notes on it or anything. But that's the basic idea of today's lesson. Make sure you always factor out the greatest common factor to start with. And then once you've started factoring, look at your individual factors and see if you can factor further in order to get it fully factored. So if you have any questions on your homework, I'll be walking around and I can help you guys out with them. And I'm also happy to go through any examples as a group on the board if that would be helpful.